All right, welcome everybody to the second week of your virtual learning classroom. Obviously this week back to me videotaping. Hopefully you're out there going through the first week and asking any questions that you've gone through as you're going through these. Okay, all right, so first up, go ahead and look through your warm-up. Go ahead and solve these 4 problems. Either I would have printed these out from my website, or you can just write them off the guided note sheet or in a notebook somewhere. So go through these 4 problems. Numbers 1, 2, 3, try not to use a calculator. Number 4, more than welcome to use a calculator. Real quick on number 4, since you don't have our normal school blue calculators, you may be using whatever calculator you can find at home. Little hint, if you could Google any type of calculator off the internet, use your cell phone. Remember, if you turn it sideways, there's a bunch more scientific functions that are on there. Or you could use the link that I posted on my website that gets you as close to one of those blue calculators as I could find for you. So again, at this point, I would pause the video. Your warm-up should take you about 6 to 8 minutes if you're on pace with everything. So pause the video at this point, and when you're ready, unpause it and I'll go over it. All right, now that you've unpaused the video, number 1, we need to over, under, and distribute each answer choice, and we're looking for something that is equivalent to negative 15x plus 39. Answer choice A, negative 3 times 5a is negative 15x. Negative 3 times negative 39 is positive 39. That's what we were looking for, so answer choice A is exactly the right answer. Real quick, I will show a couple of the wrong answers. Answer choice B would give me negative 15x minus 39. A negative times a positive is a negative. Answer choice C would be positive 15x. Well, I'm going to stop right there because I know I'm looking for negative 15x. Answer choice D would also do the same exact thing. It would start off with positive 15x, and I wouldn't worry about even finishing that problem. Number 2, we are looking for an event that has a 50% chance of occurring, or something that is equally likely. Well, answer choice A says rolling a 2 on a number cube. Well, I wrote out the 6 numbers that make up a normal die, and I wrote 1, number 2. So there is a 1 in 6 chance. 1 divided by 6, or 1/6 FD, is about 16%. We were looking for something that is 15%. Answer choice A is eliminated. Answer choice B, rolling a number that is less than 5. Well, 4, 3, 2, and 1 are all numbers less than 5. You have a 4 in 6 chance, which is approximately 66%. Again, we're looking for 50%. Answer choice C, well, we're spinning a spinner with 3 different colors. 1, 2, 3, blue, yellow, red. Well, that's an odd number of numbers. It can't have an even percent, but right there, I'm going to eliminate it. It had a 1 in 3 chance of landing on the color blue out of that spinner, about 33%. So answer choice D should be our answer, but let's go ahead and solve it anyway. Rolling a number greater than 3, that would be the numbers 4, 5, and 6. 3 out of 6, 3 divided by 6, or 3/6 is equivalent to exactly 50%, giving us our final answer. Number 3, again, you would never see a calculator on this, so the easiest way to perform these problems is to go ahead and find the temperature at every single time. So the temperature started at negative 12 at 6 a.m. The temperature increased. Well, I think to myself, that means the temperature is rising in the positive direction, a half a degree for each hour for 6 hours. What was the temperature after the 6 hours? So I need to find the temperature at 7, 8, 9, 10, 11, and then 12 o'clock. That would give me all 6 hours. Well, I'm thinking to myself, it went up a half a degree from here. Well, that would mean that it's getting closer to 0, so it must have went to negative 11.5. If it goes up another half degree, we are now at negative 11. It goes up another half degree, we are now at negative 10.5 degrees. It goes up again, negative 10. It goes up again, negative 9.5. And when we got to 12 o'clock, it would be negative 9 degrees total. Number 4, again, without having a calculator that would be able to make a list and run through the statistic program like that, you're going to have to add up all the numbers. So I added up these 8 numbers. I got a sum of 289. I listed how many data points by just counting carefully. 1, 2, 3, 4, 5, 6, 7, 8 different numbers I added together. Again, I take the sum, I divide it by the number of data points, and you should have got a mean that was approximately 36.125. All right, on to your notes for today. So today we will be covering how to solve the surface area of a three-dimensional figure. So we have about 4 different types of figures we're going to start going over. They are basically have to do with triangles and 4-sided shapes, squares, and rectangles. So definitely want to still know our difference between area and perimeter. Remember, the perimeter is the distance around. So on this picture, it would be the black line that goes around this shape. And then the amount covered on the inside of the shape, that's our area that would be represented by all the red. Now, we're going to use that information. We're going to be working on a lot of area this week. We will get back to the volume or the perimeter stuff in upcoming weeks. So, first up, we're going to cover the area of squares and rectangles as a quick refresher. Remember, we use that, find the area of a 4-sided shape, length times its width. A equals length times width. So up here, I have a basic rectangle with the dimensions 12 centimeters by 3.5 centimeters. Always start off by writing your formula. Since you're starting to get to multiple formulas in 7th grade, you know the area of a circle, the area of a 4-sided shape, and the area of a triangle. You have 3 area formulas. Always list which one you need first so that you don't accidentally use the wrong formula. I listed the length times the width, 12 times 3.5, and I would have gotten a final answer of 42 centimeters squared. Remember, we always use units that are squared for area, so centimeters squared or centimeters to the 2nd power. Again, length times width, that works for squares and rectangles. So up here, take about 4 minutes. You may not even need that much time. Go ahead, pause the video, write down your formula for all 3. Number 3, think about maybe drawing a picture to help you out, but like I said, it should take you about 2 to 4 minutes to work out these 3 problems. Pause the video at this time. When you're ready to go, unpause the video and I'll be here for you. All right, now that you have unpaused the video, up here, let's go over number 1. Well, these marks, the first thing I had to think to myself, well, it looks like a square. It is a square because they have congruent marks. Congruent marks let me know that each place has the same value. So area, length times width, area, length times width, 4 times 4, we would get an area of 16 square meters. Number 2, we have a rectangle. Again, uses the formula length times width. I took my length, 3.74, I multiplied it by my width, 0.8, and I got approximately 2.992 square feet. And now the third one down below, the first thing I did was I read it. A rectangle has a width of 7.5. The length is twice as long as the width, and we need the area. So I wrote my area formula. I drew a picture of what they gave me. I then took that information. It said twice the width is the length. So I multiplied 7.5 times 2 to find that the length was 15. Now I know my length and my width. 15 times 7.5, and you should have got 112.5 square centimeters. Again, pretty basic. This should be all a quick review from 5th and 6th grade. Moving on, now we are going to use this skill to apply to 7th grade word problems. So, first up, I have a great example here to model with you. A kitchen shaped with a rectangular dimensions of 11.5 feet by 9.5 feet. The floor of the room is made up of square tiles with a side length of 1/2, and they want to know how many number of tiles will cover the kitchen floor. Well, right here, I got a bunch of information. I know that they gave me a rectangle with dimensions. So the first thing I went through was I made sure to draw a picture of my rectangular room. They also talked about square tiles. So down below, I drew out my square tiles. So again, I haven't done any math at this point. All I've done is taken the words in the problem and drawn some pictures to make the math a little easier. Now, if I keep reading, it says, what is the number of tiles that will cover the floor? Well, this right here, I got a key piece of information. They're talking about putting tiles down on the floor, and they're talking about covering it. So right there, again, I knew that this was eventually going to be an area problem. Well, what they're trying to see is, how many of these smaller tiles can I take and place inside the room so that I can end up covering the entire floor? Okay, well, I think if I could find the area of the floor, I can know how much space I total have. So first up, length times width for my rectangle. Length times width, I would have gotten approximately 109.25 square feet. Okay, so square feet. So now I know that's the total that I have to work with, 109.24. And again, I'm trying to see how many of these smaller tiles can I fit inside here. Well, they don't all have a value of 0.5. I need to figure out what is the total area each little piece has. So again, I could find the area of each square rectangle. Length times width. A half times a half, or 0.5 times 0.5, would tell me that the volume of each little piece on the inside of these would be 0.25. Well, now again, I know how much room I have to work with. I have 109.25 square feet to work with, and I know that each one of these little tiles has an area of 0.25 square feet. The last step is asking me, well, how many of these little tiles can I fit inside of this larger figure? Well, in order to solve that, I'm going to have to go to a third step. I need to figure out the total and split it up into those smaller spots to find out that I would end up having to use 437 tiles. If you ever go to redesign a room, a kitchen, a bathroom, anything that has square units, you can actually, this is what real people do. They don't just go buy a bunch of material and see, hey, do I got enough? They figure it out mathematically. They figure out the size of the room they're working with. How big is the material they want to lay down? And then how many do I have to buy so that I make sure I have enough and I'm not wasting my money on buying too many? So again, multi-step problem, but none of this is difficult. The first part was reading and writing it down. The second part was finding the area. The last part is a little bit tricky, but you would have to think to yourself, what could I do with the area of both the room and the tiles that they're trying to fit inside? So, use that example to try these two out. This may take you about 4 or 5 minutes. Work through each problem. Make sure you're drawing a picture. Think about how you can take the larger room and then use the smaller tiles to fit into the room. Again, go back in this video if you're confused at all, but I would pause it at this point and try these two. When you're ready to go, unpause the video, and again, I'll be here for you. So at this point, you should have tried these two problems. Let's take a look. The first one, a kitchen with a rectangular room with a length of 12 and 15. Okay, well, I think to myself, maybe I should draw a picture. So boom, right here, I got my picture of this. It talks about square tiles. Second part I did, I drew out my square tiles. Again, it talks about covering the floor. Well, automatically, I know this is going to be an area problem, length times width. Well, to find the area of the big room, I took my length and width, 12 times 15, and I found out the inside area of this room is 180 square feet.
Can I have your attention,
I'm going to let one
please?
announcement go through real quick.
Ms. King, could you please come to the office?
All right, now that we got our announcement out of the way, we know the total square footage of our room. Again, we have to find how many of these will fit inside. But again, it's not 180 divided by 1.5 because that is just the length of the square tile. The edge of a square tile. That means the length and the width are going to be the same, meaning I have to do 1.5 times 1.5 to figure out that each little guy here is going to be 2.25. Well, now that I have my area of my room, the area of each tile, again, I just divide the two and I would find out that I would need 80 tiles to completely cover that floor. Second example, same exact kind of concept. The only difference is I changed up the type of room we had. We're working with a square bedroom with dimensions 12 by 12, length and a width of 12 by 12. They are putting carpets that measure 2 by 2, length and a width for each square part of carpeting. How many pieces of carpet will they need to completely cover the bedroom floor? So again, first thing I did, I drew out my two shapes. I have a square bedroom and square pieces of carpet. It talked about covering it, so again, I know that I'm using my area formulas, length times width. To find the area of the bedroom, I did 12 times 12, and I got 144 square feet. So again, the inside of this bedroom is 144 square feet, and I'm trying to figure out how many 2 by 2 square carpets can I fit on the inside. Well, again, I've got to figure out the area of my carpet pieces. Again, I can do that by finding the area of each piece. 2 times 2 is 4 square feet. So again, I know that the larger room has an area of 144, and I'm trying to figure out how many square carpet pieces I can fit on the inside. Last step, I'm going to divide the two. 144 divided by 4 would mean that there would be 36 of these square carpet tiles that fit inside a room with 144 square inches. So that is the notes for the squares and rectangles today. We'll quickly go through triangles. Know one of your two formulas. It depends what you were taught, but whatever you were taught back in 4th, 5th, and 6th grade, I would stick with it. I usually use area of a triangle is equal to 1/2 times the base times the height. But if you were taught base times height divided by 2, they always give you the same exact answer. So again, you pick one of these two ways. It's up to you. They both work. Now, the hardest part is knowing where to find the base and the height. The base and the height are always located where a right angle in a triangle. So in an equilateral triangle or a scalene triangle, anything that's not a right triangle, there's usually not a right angle, but they basically will give it to you in 7th grade by putting a dotted line from the height of the prism all the way down to the base of the triangle. So wherever that right angle is formed, those are the two numbers we would use. So right here, if I was to multiply, if I knew the values of the height and the base, I would have 1/2 times the base times the height. Again, for this triangle, they told us right here, hey, that's a right triangle, 1/2 times the base times the height. Again, you need to know your formulas. Areas of circles, areas of squares and rectangles, area of triangles. Down below, or on the next slide, height is how tall a triangle measures. The base is the flat side. The hypotenuse, the slanted side, is something that we don't need in 7th grade. Again, I'll pause for a moment.
BMTs report to the main office to help with gathering Chromebooks. All BMTs report to the main office to help with gathering Chromebooks. Thank you.
My apologies on the pause again. The two sides that form the right angle, again, are the two sides that you're going to want. So we want the base of the triangle and the height of the triangle. Those two values is what we will use. So up here, what two sides would I use for this triangle? Well, I know that the right angle is right here. What two values are touching it? A is the base, C is the height, B is the distracting hypotenuse, which is something that we won't use in 7th grade, something you will definitely learn to use in 8th grade. So if I was to solve for this problem, I would do 1/2 times the value of A times the value of C, and that would tell me the area of this triangle. Again, the second one, well, this one is an equilateral triangle. They gave me 4 different measurements. I find my right angle. It's right there in the middle. I would do 1/2 times the two values that would touch this. The base is on the bottom times D. The height is touching the right angle times E, so 1/2 times D times E. Again, H and I are distractors. They're trying to tell us other information that we don't need right now for area. And last one, we do have a right triangle. There's my right angle. I'm going to do 1/2 times J times F would give me whatever my area would be. Oops, sorry, I'm crossing out the wrong two. Those are the two that I do want. I'm not going to use H, the hypotenuse. Okay, so down below, I actually have some with some numerical values on them. If you'd like to try these real quick, go ahead and go through them. But again, I gave you pretty much all 3 sides of a triangle or all the dimensions. Go through, think about what two you need. Pause the video if you'd like. I'm about to go over them now. So the one on the left, again, I locate my right angle. Here's my right angle. I know that I'm going to use the height of 5 and the base of, the height of 12 and the base of 5. 13's distracting me. 1/2 times the base times the height, area of 30 units. Second one, I find my right angle, it's right there. I have 1/2 times base times height. Again, these extra 7s are just there to distract me. 1/2 times 7 times 7.5, 26.25 square units. On to the next page. Again, try this one out on your own. If you didn't try any of the other ones, pause the video, and when you're ready to go, unpause. All right, here we go. Again, first thing I did is I looked, it says, what is the area of this triangle? So I know I need 1/2 base times height, or base times height divided by 2. I find my right angle, it's right here. I know that I'm gonna use the base of 3 and the height of 4. That 5 is there to distract me. So I'm gonna write out what I'm gonna type in my calculator, 1/2 times 3 times 4, and I would find that I would have 6 square inches for my area of my triangle. At this point, definitely need to try a couple on your own, so pause the video, try these 3 out. Should only take you about 2 minutes. Write down your formula, plug in your numbers, pick up your calculator, do that third. Try these 3 out. All right, now that you tried these 3 out, let's go over these 3. First, top left one, we have 1/2 base times height. I have only 2 numbers. They didn't try to distract me too hard, so 1/2 times 11.5 times 6.5 is 94.875. Second one, we have a right triangle. They did give me all 3 measurements. Again, I located my right angle. I got rid of the number I don't need. 5 is my base, 12 is my height. 1/2 base times height, 1/2 5 times 12 gives me an area of 30. And the very last one on the bottom, just not to try to trick you, a quick review. Remember, it's not 1/2 base times height. For a rectangle or square, we have a length times a width. 15 times 4, 60 square centimeters. That does it for today's lesson. So the classwork bit.ly is located here. It'll also be on my website. It's 12 questions. It takes you to a problematic, show your work for each one, list your formulas as you need them. Any questions, you can email me or email myself or Mr. Smith. All problematic bit.lys will be uploaded either the night of or the next day in the morning. You're more than welcome to try to redo scores of any low scores. Email us if you have any questions.